So today we're going to learn about two things. One, find the probability that an event will not occur. And that's what we call the complement of what will not occur. We also write that as a little line, prime, I guess you could call it, E prime. That just means probability of that event not happening. So if you see that little dash, what do you call that in English? Apostrophe maybe? That's what that means, not. And then sometimes you're curious about the probability of two events happening. And we'll talk about how to do that. The probability of something happening and the probability of something not happening should equal 1. Right? So if someone walked in this room and randomly selected one of us, the probability of a girl is 1, 2, 3, 4, 5 out of 6, right? Probability of a boy, 1 out of 6. You take 5 over 6 girls plus 1 over 6 boys, you get 6 over 6, which is 1. So the probability of something happening and the probability of that something not happening always adds up to 1. Make sense? So let's say you are dealt one card from a standard 52 card deck. So I'll pull out these little cards again. Find the probability that you are not dealt a queen. Well, what we could do is, what's the probability of getting a queen? Probability of a queen. That's what that means. P and in parentheses, that means probability of getting a queen. What did you say, Christina? Okay, so you already got it, but the probability of a queen would be, how many queens are there? 4 out of 52. So then the probability, make sure of not a queen if only 4 out of 52 of those cards are queens, then that means how many cards are not queens? 48, right? Does that make sense? So there's a 48 out of 52 of those cards are not queens. And notice 4 over 52 plus 52 equals 52 over 52, which is 1. 48 over 52. If you reduce that, it's 12/13. Right? And if you wanted that as a decimal or a percentage, that would be around 0.92. So you have around a 92% shot of pulling a card out and it not being a queen, right? So there's a queen, right? Not a queen. There's 4 more queens. And then all the rest of these aren't queens. So there's 4 here, 48 that are not. So that's why you have almost a 92% shot of picking a card that's not a queen. Questions on that? Justin is participating in a lottery game. His goal is to correctly guess 4 different numbers from 1 to 20. If he guesses them right, he wins $2 million. What is the probability that Justin correctly guesses the numbers? Well, I see 4 different numbers from 1 to 20. Does order matter? No. It doesn't say he has to guess them in the right order. So we have 2 functions. We have permutation and combination. So if order doesn't matter, this would be a combination. Now, there's 20 different numbers, so that goes in front, and he's picking 4. And again, I showed you before how to do this mathematically. So equals 20 factorial over 20 minus 4 factorial and 4 factorial, remember that? But I'm just going to type it in the calculator. So 20 math PRB, go to the C function, 4,845 different combinations. Probability, because it doesn't say how many different combinations are there. It said, what is the probability? Well, how many combinations of winning numbers are there? There's only how many sets of winning numbers? Well, you're picking 4 numbers, but there's only one combination of those 4 numbers that's a winner. Right? So our probability would be 1 out of 4,845, which is approximately 0.02. And I'll just leave it like that. There's no point writing as a decimal. So you have a 1 out of 4,845 of winning $2 million. I would take it. Would you? You only have to buy almost 5,000 tickets, and I don't know how much each ticket costs. You'd win $2 million. That's a good investment. What is the probability that Justin doesn't correctly guess the numbers? Well, if there's one combination that is correct, then how many combinations are not correct? Yeah, 4,844. Out of 4,845. And that's the probability that Justin doesn't correctly guess. You can see, and you can convert that to a percentage, and you know how to do that. I'm okay with the fraction in the homework if you want. Or if you want to write all 3, that's okay too. But yeah, there's 4,844 combinations that are not correct. Questions on that? And we have something in math that's called mutually exclusive. All that means is that there are events that cannot occur at the same time. You'll see what that means here in a minute. So all we've learned so far is that if you take the probability of something happening and the probability of that not happening, it always equals 1. That's all we've learned. Now, let's find the probability of a second event occurring. So there's the word or in math. And the probability of being a boy or a girl in this room, well, isn't that mutually exclusive? Can you be, keep using gender as an example, but more than likely than not, or in here we're either female or male, right? So to find the probability of selecting a male or female, that would be 100%. So the probability of A or B, you just add the probabilities. If they're mutually exclusive. If one has nothing to do with the other. But if they're not mutually exclusive, where one does have an effect on another, then you add them, but then you subtract off where anything that is the same, or that could happen in both scenarios. For example, if you roll a single-sided die, what's the probability of rolling either a 4 or 5? What's the probability of a 4? 1 out of 6. What's the probability of a 5? Can you roll both a 4 and a 5 at the same time? No. Therefore, it's mutually exclusive. So you can just add the probabilities together. Does that make sense? So, we just do 1/6 plus 1/6, which is 2/6. Which reduces to 1/3, which is 0.33, which is 33%. Right? I'll just leave them as fractions. Does that make sense? We would be using this formula if you could roll and get the same number at the same time. But there's no possibility of that. It's going to land on one number. So it's mutually exclusive. A family has 8 members. And in that family, 3 are males, 5 are females. And 2 of those family people are randomly chosen to cook dinner every night. How many different combinations of family members can cook dinner? Does the order matter? No. You get to cook dinner. How many total people are in this family? 8. And how many get to cook dinner? 2. So 8C2 28. So there are 28 different combinations. That's kind of nice. So if you have a family that's 8 people, and there's around, 28, 29, 30 days in a month, then every single day you could have a combination of 2 people cooking. That'd be kind of fun. Now, what is the probability? Now, that said how many different combinations? This one's saying what is the probability of 2 males being chosen to cook, or, keyword or, 2 females. Now I need to point out, if this said what's the probability of 2 males and 2 females, then that changes the problem, because that would be assuming that you could be both male and female. Okay? Well, what's the probability of first male and female? Technically, I think this worksheet's outdated, but it's supposed to be now. It used to be now, but nowadays things have changed, right? But more times than not, you select male or you select female. So I would say they're mutually exclusive. But if you did know a case, then you would subtract them out, okay? So all that means is I could do both probabilities, because you can't be both male and female, assuming. So what's the probability of 2 males? Well, how many combinations would involve 2 males? How many total males are there? And you're picking how many? 2. Which means no females, because there's only 2 people. So if you do 3C2, you get 3. There's 3 combinations of both being male. Does that make sense? So you have male 1, male 2, male 3, and then in this family, you have what, 5 females? Female 1, female 2, female 3. So if you're picking 2 of them, you could have male 1, male 2. You could have male 1, male 3, or you have male 2 with male 3. Right? There's only 3 total combinations where both are male. Does that make sense? Which is how we got 3 there. So we would say there's 3 out of 28 total combinations that are all male. Now there's more. Now the probability of 2 females if you're picking 2 people, well, there's how many total females to pick from? 5. And you're picking, order doesn't matter, you're picking 2, right? So there, how many total combinations could be all female? 10. Meaning 10 out of 28 of those. So we could list those real fast. It could be female 1 with female 2, female 1 with female 3, female 1 with female 4, female 1 with female 5, female 2 with female 3, female 2 with female 4, female 2 with female 5, female 3 with female 4, female 3 with female 5, and female 4 with female 5. 10 combinations of both being female. So you have 10 of these, you have 3 of those, but you could have male 1 with female 1, right? You could have males and females mixed together cooking. So we don't have anyone in this family that is both male and female, okay? So because these are mutually exclusive, I could just take 3 over 28 and then add on 10 over 28, and I get 13 out of 28. So there's 28 combinations, and 13 of those are same gender. That means there are 15 combinations that are not the same gender. So about half the month, you'll have 2 boys or 2 girls, and the other half the month, you'll have a boy and a girl cooking. So when you have 2 boys, then I guess dinner's not going to be very good, right? Half the month. Well, I guess that'd only be 3 out of 28 days. I shouldn't say daily occurrences. Total possible. Questions? Now, some events with the or that are not mutually exclusive, we need to subtract out what they have in common. So, for instance, what is the probability of rolling a die and getting an odd number? What's the probability of rolling a die and getting an odd number? 3 out of 6. Because it's 1, 3, and 5 are all odd. What's the probability of getting a prime number? Is 1 prime? Nope. Some textbooks call 1 prime, but almost every textbook I've seen say no. Okay, so 1 is not prime. 2? 2 prime? Yep. So we got 1. Well, 2, I mean. 1 number. Is 3 prime? Yep. So 2 and 3 are prime. Is 4 prime? No. Is 5 prime? Yep. So we have 5. And is 6 prime? No. So the probability of getting a prime is 3 out of 6. So the probability of odd or prime is 3 over 6 plus 3 over 6 equals 6 over 6. So what that's saying is, no matter what, I will always get an odd or prime number. Is that true? According to my calculation, you always get odd or prime. Let's go through. Is 1 odd or prime? Yes. Is 2 odd or prime? Is 3 odd or prime? Yeah. But it's actually both, right? Is 4 odd or prime? No. It's not either. But we just 100%. Because we need to take out the probability of odd and prime. How many numbers are both odd and prime? And I'm a visual person, so we have the number 1, 2, 3. So we say odd was these, right? Odd. And then we said prime was these. Right? So this is not a mutually exclusive event because some numbers are both odd and prime. So how many of those? Did I miss one? I think it's just 2, 3, and 5 are both odd and prime. Yeah, you're right. I couldn't see. So 2 is not odd. So it's just 3 and 5 are both odd and prime, right? So the probability of odd and prime is 2 out of 5. So we need to actually, or I'm sorry, why did I get 5? 2 out of 6. 2 out of 6 of those numbers are both odd and prime. So when they're not mutually exclusive, you need to subtract it off.